In 2.1, we're going to look at perpendicularity. The first objective is that you need to recognize the need for clarity and concision in proofs. We've mentioned brevity is beautiful. And then you need to understand the concept of perpendicularity. So now we have a new definition. Lines, rays, or segments that intersect at right angles are perpendicular. So to say this conditionally, we would say if lines, rays, or segments intersect at right angles, then they are perpendicular. So if you have a right angle, then it's perpendicular. They are perpendicular. So lines, rays, or segments that form a right angle implies perpendicularity. And this is a definition. Definitions are reversible, so that's biconditional. Some examples of perpendicularity. Here, line A is perpendicular to B. Segment DE is perpendicular to segment EF. And segment JM is perpendicular to segment GH. Now notice I could have marked all four angles, but you only need to mark the one. Let's look at some examples. Given segment AB is perpendicular to segment BC. Segment DC is perpendicular to segment BC. So we're going to start with our first given. AB is perpendicular to BC, that's given. So why is B a right angle? Because if segments are perpendicular, then they form a right angle. Now I would have combined steps 1 and 3 and 2 and 4, but the book didn't. So we'll go through this again. DC is perpendicular to BC, we marked that. If segments are perpendicular, then they form a right angle. That comes from line 3. And now we have two right angles. If two angles are right angles, then they are congruent angles. And that comes from lines 2 and 4. When we get more into chapter 3, you'll be required to do the number in the parentheses. So I inferred perpendicular implies right angles from line 1, perpendicular, right angle. And then this reason came from line 3. And then the fifth reason came from lines 2 and 4. Now, I am saying B is congruent to C, angle B is congruent to angle C, so I'm going to mark that again with a tick mark on the diagram. In problem 2, we are given EH. Line EH is perpendicular to line HG. Line EH is perpendicular to line HG. So the right angle's up there. So all the right angles that we have are EHG. Notice the repeated H. You cannot make the inference that either of these angles at F are perpendicular or right angles. In problem 3, we have an algebra problem. So we want to do DQs. Remember, D stands for diagram, K is for key, E is for equation, W is for work, and then S is for solution. So given ray KJ is perpendicular to ray KM, here we have the right angle and it's marked. Angle JKO is 4 times as large as MKO. Whatever is mentioned second in your algebra problem, that's X. And then the other object is written in terms of X. So now we have our diagram and our key. Those are together. Now I need my equation. Well, if this is perpendicular, we know that perpendicular implies a right angle, and a right angle is 90 degrees. So we can say 5x equals 90 degrees, then x equals 18. Find the measure of JKO. The measure of angle JKO is 4 times 18, and I don't have a calculator, so I'm going to do it this way. That's 40 plus 32, or 72 degrees. In the fourth problem, we are given that A is perpendicular to B, so angle 1 would have been better to mark as the right angle. We are given that C is not perpendicular to D, so angle 2 is not a right angle. We know that it's kind of hard to prove this one until we get to chapter 5, where we'll do the indirect proof, but we're given A is perpendicular to B, and we know that perpendicular implies a right angle, so angle 1 is a right angle. We're given that C is not perpendicular to D. If it's not perpendicular, then it's not a right angle. So angle 2 is not a right angle. So angle 1 is not congruent to angle 2. This cannot be proven. You're not going to end up with something like that in your homework, but that's just an introduction to future work. Given EC is parallel to the axis, x-axis, and so is RT, that means these two are actually parallel to each other. That'll come up in chapter 5 as well. What it's telling you is that you can then infer point T's coordinates. So that's going to be the x value from here and the y value from here. Then 3 minus a negative 2 gives you the length of that side is 5. And 7 minus a negative 4 is 11. So that's that side. An area of a rectangle is the base times the width. So 5 times 11 is 55. If you found this video helpful, please like and subscribe. Smash that like button. You know you wanna. Come on, give it a thumbs up.